We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system now. Astronomers.
That night, the sky seemed quiet, but a faint signal from the Atlas telescope in Hawaii shook the entire scientific community. Michio Kaku called it a discovery that sent chills through the world. An unknown object was racing through our solar system at a terrifying speed, faster than anything humanity had ever measured, and it carried mysteries that went beyond every theory we had. Within hours, observatories across the globe confirmed it. This was 3I Atlas, the third interstellar visitor in history. The question is clear: is it only a wandering block of ice, or a sign from some distant intelligence? To find out, we need to start with the moment of its surprising discovery. The discovery of 3I Atlas began with a faint streak of light in the sky, something that astronomers in Hawaii almost missed among the thousands of signals recorded each night. On July 1, 2025, the Atlas telescope picked out a small moving dot against the background stars of the Milky Way. Within hours, the alert system showed that this was not an ordinary asteroid or a comet from our solar system. The first calculations of its velocity made it clear that the Sun's gravity could never keep it bound. In other words, its orbit was hyperbolic, an open path that revealed it had entered from somewhere far beyond. As soon as the first data was shared, observatories from South Africa to Chile pointed their instruments to the same target. In less than 24 hours, confirmation was made. This was only the third interstellar object ever observed by humankind. Before Atlas, there had been only Oumuamua in 2017 and Borisov in 2019. The fact that another visitor appeared so soon left scientists both excited and uneasy. 3 detections in less than a decade suggest that many more objects like this may pass near our solar system, hidden in the dark until the right moment. To understand why this was such a breakthrough, we need to compare it with the familiar motion of planets and comets bound to the Sun. Every world in our system, from Mercury to Neptune, moves in closed loops because the Sun's pull locks them in place. 3I Atlas was different. It cut straight through the solar system without slowing down, like a traveler stopping briefly before continuing a journey that would never return. This is direct proof that our system is not isolated, but instead part of a larger flow of material that moves across the galaxy. Scientists stress the value of such a rare chance. Each interstellar object is like a natural sample from another system, carrying the history of its birth billions of years ago. By observing and analyzing them, we gain access to information about alien environments that no spacecraft could reach. For this reason, Atlas became the focus of global astronomy, with telescopes competing to gather every possible detail before it faded from view forever. The sense of urgency was not only scientific, but also emotional. Humans have always wondered if the stars send messages across the void, and now a fragment from another system was crossing our sky. Every measurement was a chance to unlock secrets about worlds that may have vanished long before Earth was born. This single object turned into a messenger from deep time, and scientists knew that missing it would mean losing answers that might never come again. The big question now is, why did its velocity shock experts so deeply, and how could such speed reshape our understanding of what an interstellar visitor really is? When the first numbers for the velocity of 3I Atlas were released, many scientists could not believe them. The object was racing at nearly 137,000 miles per hour, which means more than 61 kilometers every single second, and this was far beyond anything humanity had ever recorded from a comet or asteroid. To make the speed easier to picture, Imagine that a bullet from a rifle only reaches about 2,500 miles per hour, and even NASA's Parker Solar Probe, the fastest spacecraft we have ever built, moves at only a fraction of Atlas's pace. If this visitor crossed the United States, the trip from New York to Los Angeles would take less than 2 minutes. Yet the shocking part was not only the raw speed. An object with significant mass moving at such velocity holds a terrifying amount of kinetic energy. If it were ever to strike a planet, the release would be thousands of times more powerful than the biggest nuclear weapon humanity has ever tested. This is not science fiction, but a direct calculation from physics, and it explains why astronomers quickly began to pay closer attention. Fortunately, the projected path showed no danger to Earth, but the possibility itself was enough to raise alarms in the scientific community. Another feature that stood out was the nature of its orbit. Planets and comets inside our solar system are tied to the Sun's gravity and follow closed elliptical paths. Atlas, however, is different. It travels on a hyperbolic orbit, which means it is unbound and will never return. The Sun, powerful enough to trap billions of bodies for billions of years, had no effect on this interstellar traveler. This escape path is one of the clearest signs that Atlas is not from here, but from some other corner of the galaxy. The extreme velocity raised deeper questions. What force could possibly launch a mountain-sized block of ice and rock to such incredible speeds? Astronomers suggested scenarios involving violent collisions in a young planetary system or strong gravitational interactions near giant planets that acted like cosmic slingshots. Some even considered that it might have been expelled during the chaotic birth of stars billions of years ago. Whatever the cause, the outcome is the same. The universe has the ability to send projectiles flying at speeds that dwarf anything humans can create. The unsettling thought is that one day, a similar object could be aimed directly at Earth. This is why planetary defense programs have gained more attention in recent years. The speed of 3I Atlas is not just a number in a scientific report, it is a warning about our vulnerability in a universe filled with unpredictable events. Human civilization is advanced, but compared to forces like this, we remain fragile. Building systems to detect, track, and potentially divert dangerous objects is not just a future project, but a survival necessity. In the end, Atlas's speed is a reminder that the cosmos is not a calm or predictable place. It is a realm where objects can carry unimaginable power, moving silently through the dark until they appear without warning. And while this particular visitor will not harm us, it leaves behind a question that cannot be ignored. If speed alone is this shocking, what mysteries hide inside the very chemistry of this ancient traveler? The energy carried by 3I Atlas is not just a theoretical number, it is a potential threat that has kept many scientists awake at night. With its extreme velocity, even a single collision in theory would release more power than thousands of the largest nuclear explosions in human history. This fact alone forced the astronomy community to admit that our planet, no matter how advanced our technology may be, is still fragile when faced with visitors arriving from the depths of space. Experts in planetary defense were quick to connect this reality with ongoing projects. NASA has been testing the DART mission, crashing a spacecraft into an asteroid to change its orbit. The European Space Agency is working with several countries to create early warning systems for near-Earth objects. But all these plans are designed for bodies that move within the solar system, where scientists have time to predict their approach. For a cosmic missile like 3I Atlas, arriving from billions of miles away at a speed far beyond our standards, humanity has almost no way to react in time. The problem is not only the speed, but also the scale of kinetic energy. According to estimates, an interstellar body a few hundred meters wide, moving at this pace could produce an impact equal to millions of megatons of TNT. This comparison is terrifying when set against the Tunguska event of 1908, which was only about 10 to 30 megatons, yet still managed to flatten over 2,000 square kilometers of forest. If something like Atlas ever struck, the consequences would be far beyond human imagination. Such scenarios are not meant to create fear for the sake of fear, but to highlight the importance of preparation. Humanity needs stronger detection systems, more accurate prediction models, and eventually technologies that could deflect or redirect dangerous celestial bodies. The arrival of 3I Atlas works as a cold reminder that we live in a universe that is not safe, and that every moment of calm on Earth is only temporary. It shows that ignoring the sky is no longer an option, because what we fail to notice could one day change the fate of our species. The urgency also connects to questions of responsibility. If global cooperation can build networks to monitor weather or control nuclear arsenals, then surely it must also be able to guard against threats that come from outside our planet. The debate is no longer about whether such defense is necessary, but whether humanity can organize quickly enough to be ready before the next visitor arrives. Still, the biggest mystery has not yet been answered. Beyond the incredible energy, does the unusual chemistry of 3I Atlas hold the true key to its origin? That question leads directly to the next part of the story, where the details of its chemical signature turn the mystery even deeper. What scientists expected at first was a familiar picture: water dominating the gases released, just as in almost every comet ever observed in our solar system. Instead, the James Webb Space Telescope delivered a result that no one had seen before. Carbon dioxide overwhelmed the readings, creating a ratio of 8:1 compared to water. In solar system comets, water usually takes the lead, and even in rare exceptions, carbon dioxide is only a small fraction of the total. This meant that 3I Atlas had either formed in an environment unlike any we know, or it had been reshaped by a process that does not exist near our Sun. When researchers compared the data with current models of comet formation, they found a serious gap. If the object had formed beyond the so-called CO2 ice line, where this gas can freeze into solid ice, then water should have remained locked even farther out. Yet the evidence suggested the opposite. Water had been stripped away, leaving a crust dominated by carbon dioxide. Another explanation pointed to radiation from a massive star or even the blast of a supernova that could have boiled away the lighter ice and left the heavier molecules intact. Still another idea suggested that billions of years drifting through interstellar space had allowed cosmic rays to alter the surface chemistry, gradually creating the strange pattern we see today. While these possibilities were debated, another shock came from the Very Large Telescope in Chile. Instead of finding both nickel and iron, as has been the case for every comet studied so far, the spectrum only showed nickel. This was unusual because the two elements are normally forged together in stellar explosions and appear side by side in comets within our solar system. Even more puzzling, nickel emissions were detected before the usual cyanide gases, which are typically the first to appear when a comet warms. The reversed sequence challenged the standard script for comet activation and forced scientists to question whether Atlas had been built from entirely different materials. These clues painted a picture of an object that is more than just a frozen wanderer. Atlas began to look like a natural sample taken from a cosmic workshop, carrying evidence of conditions no human had ever witnessed. Each measurement not only broke older theories, but also opened the door to new questions about the chemistry of other star systems. The missing iron, the overwhelming carbon dioxide, and the strange timing of nickel all suggested that the galaxy contains chemical rules far beyond those we use today. For many in the scientific field, Atlas became a rare reminder that discovery often comes from anomalies. The object did not fit neatly into existing categories, but instead destroyed the outlines of the models we had trusted. It forced experts to confront the idea that the galaxy might hold countless systems with conditions completely foreign to our experience. Yet if chemistry alone is this unsettling, then what about the path that Atlas is taking across the solar system? Could its orbit really be the result of random chance, or is there a deeper pattern that seems too precise to ignore? The orbit of 3I Atlas became one of the most unsettling aspects of the entire story because it looked nothing like the ordinary paths of objects bound to the Sun. Most planets, asteroids, and comets follow the ecliptic plane, moving like dancers in wide circles around our star. Atlas, however, plunged in from above with an inclination of nearly 175 degrees. That angle was close to a complete reversal of the solar system's usual orientation, and it marked Atlas as an outsider the very moment it was observed. Such an extreme tilt suggested that this traveler carried the scars of violent forces from another system, strong enough to eject it from stability and send it wandering across the galaxy. The mystery deepened with its predicted flybys. Within only a few months, Atlas would sweep close to Mars, then pass near Venus, and later come close to Jupiter. By cosmic standards, these distances were small, measured in only tens of millions of kilometers. Harvard astronomer Avi Loeb and his team estimated the chance of an interstellar object randomly hitting all three encounters in such a short period at just 0.005%. 1 in 20,000 is an astonishingly small probability, and it naturally triggered questions about whether the orbit was guided by chance or by something else. The comparison many people reached was with a spaceflight maneuver. When NASA sends probes to distant worlds, engineers often use gravity assist, also known as a gravitational slingshot. By flying past a planet, a spacecraft can steal a bit of its orbital energy, gaining speed or shifting direction without burning much fuel. Voyager famously used Jupiter and Saturn to head outward toward interstellar space, and New Horizons relied on Jupiter to race toward Pluto. Atlas's path looked strikingly similar, as if it were visiting Mars, Venus, and Jupiter step by step, taking momentum the way our spacecraft do when following carefully designed plans. Astronomers were quick to remind the public to remain cautious. The universe is chaotic enough to produce rare alignments, and coincidences do not prove intention. Still, the chain of unusual details was hard to ignore. Atlas was not only tilted almost upside down, but it also managed 3 rare planetary approaches in sequence, and its perihelion happened to occur behind the Sun from Earth's view. That alignment meant ground-based telescopes would miss the brightest and most informative part of its journey. For scientists, it felt like a cruel twist of fate, because the golden opportunity for observation would vanish into the glare of the Sun. Some argued that all of these oddities could still be explained by chance, while others felt that the pattern looked uncomfortably precise. The image of a natural object moving as though it were executing a mission plan was difficult to dismiss entirely. Even without evidence of design, the resemblance to human flight paths was enough to spark heated debate. In the end, the orbit of 3I Atlas did more than trace a line through the solar system. It traced the limits of human imagination, forcing us to ask whether the universe sometimes creates alignments so exact that they appear intentional. And as questions about its orbit continued to grow, another element entered the picture: the role of media and public fear in shaping the entire mystery. When 3I Atlas was announced, another race began outside the labs, the race of information. Within hours of the first data being shared, social media was filled with edited clips, misleading illustrations, and endless headlines warning of the end of the world. The striking part was that most people did not read scientific journals or official press releases. Instead, they consumed news through YouTube, TikTok, and Twitter, platforms where every small detail was inflated into proof for conspiracy theories. Fact and imagination quickly blended into a single chaotic stream. Michio Kaku became an easy target for this wave. Click-driven channels placed dramatic warnings in his mouth that he had never said, turning him into a prophet of the cosmos for millions of viewers. While research teams were carefully analyzing spectral data and comparing formation models, the online world was already convinced that Atlas was an alien probe.
The reflection of sunlight is coming from a solid surface, in which case, as you pointed out,
the gap between real science and internet science widens day by day, and once such a gap forms, it becomes extremely difficult to close again. History shows us this pattern is not new. In the 16th century, European woodcuts often depicted comets as fiery swords, paired with predictions of war or famine. These cheap prints spread fear through markets more effectively than they spread knowledge. In Asia, imperial records often interpreted strange lights in the sky as political omens, leading to unrest among the population. Again and again, humanity has chosen fear first and analysis later whenever the heavens delivered something unusual. 3i Atlas became a modern version of this tradition. Instead of woodcuts and legends, today we have bright thumbnails, dramatic background music, and bold captions flashing across phone screens. Technology has changed the format, but the core reaction remains the same. A cosmic mystery turns into a storm of misinformation. This has consequences not only for how the public understands science, but also for the level of trust they place in scientists. Researchers warn that if hype dominates, society risks losing the chance to truly study rare events. The real danger of 3i Atlas is not that it proves alien technology, but that it shows the universe is far stranger and more complex than our models suggest. But when that truth is drowned in noise, what remains is fear rather than knowledge. In a time when attention moves faster than careful explanations, the survival of real science depends on how well we can communicate. The question that now faces all of us is simple yet crucial. Can we stay calm enough to look at data instead of drama when the next cosmic visitor arrives? Because if not, the mystery itself may slip away, leaving only stories shaped more by imagination than by discovery. The search for the origin of 3i Atlas may be the most important part of its story, because it connects this strange visitor to the oldest history of our galaxy. When astronomers traced its orbit backward through the stars, the path did not match the thin disk of the Milky Way, where the Sun and planets are located. Instead, its motion lined up with the thick disk, a region filled with ancient stars that formed more than 7 billion years ago. This meant that Atlas was probably older than our solar system, carrying the memory of times that Earth has never known. To imagine this is to step far beyond human history. Civilizations rise and fall in thousands of years, but Atlas has been moving through space for billions. During that endless journey, it would have seen supernovae explode, releasing clouds of heavy elements into the galaxy. It may have passed through nebulae where new stars were being born, and then through empty regions where nothing remained but silence. Every kilometer it traveled added layers to its surface, like scars recording the events of deep time. Scientists see Atlas as more than just rock and ice. It is a natural archive, a cosmic time capsule that preserves the chemistry of an age when galaxies were young. On Earth, laboratories can simulate extreme temperatures and radiation, but they cannot reproduce billions of years of exposure to real cosmic conditions. This is why every measurement of Atlas matters. The unusual levels of carbon dioxide, the absence of iron, and the tilted orbit are not random curiosities. They are pages in a record that stretches back to the dawn of the Milky Way. The idea that Atlas predates the Sun also changes how we view ourselves. Humans often think of history as something vast, yet compared to this object, our entire existence is brief. We measure time in centuries or millennia, while Atlas has drifted for spans we can barely calculate. It reminds us that humanity is young, and our knowledge is still just a beginning. Objects like this force us to see our place in the galaxy with new humility. At the same time, they offer rare opportunities. Each interstellar object that enters our solar system gives us a direct sample from another environment, one that may no longer exist anywhere else. Atlas might have been ejected by a violent planetary migration or by a collision that tore apart an ancient system. Whatever the cause, it now travels as evidence that the galaxy is constantly reshaped by forces greater than we can control. For astronomers, studying it is like reading a letter written billions of years ago, sealed in ice and stone, delivered across unimaginable distances. This raises a final haunting question. Is Atlas nothing more than a piece of ancient debris wandering into our view, or does it carry a message that humanity has not yet learned to read? Because if such objects are truly fragments of the galaxy's memory, then each one could change how we understand not only the past of the universe, but also our own future within it. And this leaves us with the final step of the journey. What message, if any, is the cosmos trying to send through this visitor from the deep past? 3I Atlas is not just a drifting block of ice and rock. It is a test for human knowledge, reminding us that the universe still holds countless mysteries beyond our reach. From its terrifying speed to its unusual chemistry and its strange orbit, every detail of Atlas challenges what we thought we understood about space. The greatest question remains: is this only a cosmic coincidence, or could it be a message sent to Earth from the deep past of the galaxy? What do you think? Is Atlas nothing more than an ancient fragment, or is it a sign of something far greater? Share your thoughts in the comments, and don't forget to subscribe and hit the bell so you won't miss the next cosmic mystery.